All right, everybody. It is my pleasure to introduce our next keynote speaker, Adam Molnar, co-founder and vice president of strategic partnerships at company Neurable. Adam's been recognized by Forbes as a 30 under 30 honoree in consumer technology, been instrumental in bringing cutting-edge neurotechnology from the lab to everyday life. At Neurable, he leads initiatives that integrate brain-computer interfaces into consumer products, aiming to enhance mental health, productivity, and user interaction. Neurable is a pioneering neurotechnology company based in Boston, dedicated to harnessing the extraordinary potential of the human brain. Their mission is to create seamless interactions between humans and machines, revolutionizing how we live, work, and play. Beyond his work at Neurable, Adam works with leading brands and organizations to bring emerging technologies to market. He's orchestrated complex multi-million-dollar agreements with major US companies, the US military, and more. In addition to helping commercializing neurotechnology, Adam also plays a role in crafting digital policy with specific aims at biological data and its ethical applications. Adam is also an advisor to the Institute of Neuroethics, a steering member for Harvard's BCI network, and a founder of the Content Initiative for Neurotech X, the world's largest neurotechnology community. Today, Adam will be speaking on practical and ethical considerations for scaled neurotechnology. So please join me in welcoming Adam Molnar.
I'm gonna bring you around everywhere I go. Hi everyone, such a pleasure. Get in this. A lot of really nice things were just shared about me, but practically, I met this crazy neuroscientist about 10 years ago as we were transitioning some awesome IP out of the University of Michigan. And this person, my co-founder, Dr. Ramsey Zalkade, had this fundamental IP that let us use brain data out of the lab. And he asked me if I wanted to join him in creating this world without limitations, being able to control devices with our mind, being able to look at diseases ahead of our time. And my answer to that was, hell yes, that is awesome. But I told him that if we were going to get this to the level of success that we think it needs to be at, people need to fundamentally trust and appreciate what we're doing as opposed to be scared of it. So over the past 10 years or so, I've been working at the forefront of commercializing this technology, but I've also been working as like a part-time gig on biodata policy, even before large language models became as popular as they are today. So I like to ask this question: if we better understand the mind today, would we be better off tomorrow? And I think the neuroethics space is a little bit split on this. So rather than insert my opinion on it right off the bat, I want to get a little bit of a warm up. You know, it's a Wednesday, the lunch lull is hitting. Oh, sorry, but before I get to that, so just this illustrates how important understanding the mind is. Like, this affects every aspect of our lives, past, present, future, health span, longevity. And this is my slide to say that we're going to do a warm up. So just as a quick poll, hands up, maybe I'll shout out some numbers to the digital audience. Who here is wearing or owns a wearable product? Okay, it's a little bit higher than the national average, which is about 30%, 1 in every 3 Americans. We're about 50% in this room. And now what we have here is a camera, specifically a camera on a phone. Who here thinks that this is a tool?
I'm not to think of. That would be 100%.
No, not both. And who think it's a weapon? All right, 1 out of the entire room. Okay. GPS, tool, weapon. A few more folks. A drone, tool. Okay, weapon. All right, now we're seeing a little bit more folks going for weapon. Hammer, tool, weapon. Okay. I just want to point out that we just did something that's fundamental to neuroethics, but we're going to revisit that in just a moment. Oh, I'm sorry, one last one. Social media, tool, weapon. All right, a little bit more of a bias to weapon. So one last poll before I go into the full presentation, but let's say that there was some magical technology, and it was able to tell you if you were going to develop Alzheimer's at some point in your life with 100% accuracy. Who here would want to know who would want to have that information? Who here wouldn't want to know that information? All right, now let's change that up a little bit. What if it was 70% accurate that you would have a positive Alzheimer's diagnosis? Who would want to know that information? A few less hands. And who wouldn't want to have that information? A few more hands. So this is me inserting my opinion a little bit, where as a species, I fundamentally think that we're innovating faster than we can evolve. We developed at an evolutionary pace, but we're developing at a revolutionary pace. And I think that's really important when we think about the systems that we have around us, especially when it comes down to policy, which is not the fastest moving mechanism. So let's talk about some neurotechnology, do some base setting. Here are a bunch of different forms of neuroimaging: CAT scans, MRI, FNIRS, EEG. But what I'm going to focus on, it's more of my specialty, or at least my company's specialty, is around EEG. So a quick history on EEG. As you could claim that the first EEG was 1924, Hans Berger, the first time collecting voltage from the scalp and actually seeing brain activity, being like, oh, alpha. And then the next major leap, well, there were definitely major leaps between then and 58, but we have the standardization of the 1020 array. Effectively, what that did was tell everyone, this is how we should standardize sensor placement and how we should generally think about different region mapping, assessments, analysis, etc. And then lastly, a brain-computer interface, BCI. This is a system that's taking information from the brain, and different folks have different explanations. So this is my highest level explanation. Information from the brain to a computer that then outputs some kind of command to another device. And sometimes there's a closed feedback loop, sometimes there's not. But effectively, it's allowing a computer to understand data that's sometimes literally, sometimes not literally coming from the brain. And there are consumer brain-computer interface companies. My company is one of them. And one of the fundamental challenges that they exhibit is, first of all, EEG is really hard. It's a very minute data source. It's measuring microvoltage fluctuations. So when we think about these companies pursuing consumer BCI, I think of these fundamental considerations: function, cost, societal fit, comfort, and user experience. Where often, because this is such a hard technology to work with, a company will sacrifice from a product 1, 2, or even 3 of these considerations in order to get something out there. And with that, then we get to some of these common applications. So this is generally where consumer BCI is and how it's used, especially for the past 10 or so years. Meditation is a really big one. We have sensors that we put on our forehead, which may or may not be collecting actual EEG data. Oftentimes, it's also collecting EMG data, which is data from your muscles. And it's more or less sharing, are you calm or not? And some companies are using that to help with meditation practices. There are also really involved meditation research applications. There's a professor at Harvard, Dr. Matthew Sachet, who's doing some really amazing meditation work against neuroimaging. But another very popular use case is neurofeedback. How can you use this data source that it's from the organ that is the only organ that doesn't have pain receptors? You can't feel your brain. When you have a headache, that's not your brain that hurts. Those are swollen blood vessels. So neurofeedback, or being able to visualize and give some kind of texture to a data that's inherently textureless, is another application, with various levels of adoption, both consumer and medical. And then lastly, of the common applications, or at least standard for the past 10 years or so, is this idea of neuromarketing. How can you, quote unquote, take insights from the brain to help engineer a better ad or better content? How can you look at engagement, or some companies will claim, what's it called, a valence measurement of happiness to sadness, which is a little bit of a squishy science. But they use that to inform product development, what the labels look like, what colors they should use, blah, blah, blah. But today we're seeing some newer applications of the technology. And what you'll start to see is a little bit of a change in form factor. So one of those is around productivity. So how can you use insights from the brain to directly enhance things that you're doing? So if well, I already know that more than half of you have a wearable device in this room, how you use that wearable device to look at your sleep or your fitness or your overall recovery, this is what we can start to do with the brain. And companies are working on this to increase productivity and overall mental well-being, which carries over into a brain health thrust, which if you keep an eye on LinkedIn, this will become a next major buzzword over the next year or two. We're starting to see the Doppler beats bopping here and there, but we have some companies, some of them I like more than others, rolling out capabilities that are giving individuals access to their actual brain health, or at least brain patterns, and helping them understand what that means and what they can do about that. So I'll talk a little bit about my company and specifically how we got here. One of the main challenges I mentioned earlier with EEG is that it's a really delicate data source. And EEG, which being the most scalable system, still doesn't really scale beyond the lab. So we've had to work really hard to create signal processing techniques. We have about 5 novel ways that we approach this to make the data that we get from, excuse my language, cracked ear sensor usable. And because you do that, then you can take it out of the lab. And because you can take it out of the lab, then you can observe it in different ways. And this is what a visual journey looks like, where we didn't just start overnight with this consumer-facing system. We started with the medical grade 32 array 64 wet electrode, building on top of that to then get to dry, and then reducing sensor count, and then changing the kind of sensor system to a point where we have a pretty unorthodox array, but something that we believe gives value on a recurring basis. So I come back to this question. If we better understand the mind today, would we be better off tomorrow? The reason why I have this gooey organ on the slide is because when people think about the brain, it's a little bit of a charged concept. We associate it with our identity, with our innermost feelings. So we think of it as somewhat of these like last bastion of self. So I have these somewhat ethical considerations that I just wanted to walk through and use this to prime what I hope will be a Q&A afterwards, if everyone hasn't fallen asleep by the time I finish this, of some of the ways that this can be perceived. So let's say that we have a product out there that can reliably image the brain, and that's able to look at how cognitively fatigued you are. Maybe it's tracking your sleep patterns as well. And that information, it could be available to your employer. Now, maybe your employer is starting to judge you on your sleep habits or your overall recovery. Maybe what's it called, promotions and title changes is now being given to a data source that may or may not be 100% correct. But this is a possible reality that comes from exposing this kind of information. And then let's say in your future life, we have these augmented reality glasses that are integrated with sensing. Some people in this room are working on this specific problem. And it's able to tell that maybe you're developing early onset Alzheimer's. It automatically sends it to the doctor, and the doctor starts putting together a plan to help you mitigate the effects of the disease. Or perhaps the most Black Mirror, and excuse the 3 hands, although I do think that's somewhat telling, is let's say companies that are primarily ad revenue driven have access to a measure of attention. They know when you care and they know when you don't care. And they're using that to now put things into your purview or into your line of sight, helping encourage buying behaviors. So in addition to that, we have new statewide regulatory compliance. I put the 4 states that I think are leading the charge. In the US, especially, how that looks like is one state will set the highest standard of compliance, and many other states will follow suit. But what I try to put on the slide are where the differences lie. And the differences primarily lie, and I'm not a lawyer, so don't take this to the bank, in whether this falls under biometrics, meaning it's a form of identification based on biological data, or it's a form of data privacy. And that's often where neural information gets slotted to when we consider statewide legislation. And the reason why I open with the BCI brain organ and how we think of it as this really sacred state is because I think that's also what fuels a lot of our considerations around neuroethics. Whereas people crave control, and the things that they can't control become scary. Things that you don't know or don't understand become scary. Cultural zeitgeist efforts, things that we see in sci-fi or in pop culture, these all influence how we think of these. I'm not sure, but I'd be curious to know how many of the folks in the room, their first introduction to neurotech was because of Neurable. So whether there's a celebrity CEO that has interesting views or not, all of these different things affect how we feel about the brain and then why we should or shouldn't care about it. And compliance legally is the bare minimum. I'll give a little anecdote. I was speaking to a reporter who's putting a piece right now looking at the patchwork legislation. So the different rules and regulations that each state is enacting. And she asked me, like, does this affect your company? I'm like, honestly, not really, because compliance is just the bare minimum. We actually go above and beyond the bare minimum. So, and the reason why I think that's important to go above and beyond the bare minimum, and the reason why I think that neuroethics sometimes is not completely gotten right, is because there's an overemphasis and over indexing on the brain as an organ and as a neurotechnology as a tool. Now you see where the beats are coming from. But I think fundamentally, when we think about neuroethics, and really it's data ethics, it's data policy, what we really want to prevent are aspects of coercion, meaning you don't want to have a technology that's forcing you to do something, or you don't actually want an application of a technology that's forcing you to do something. And we want higher transparency. You want to be able to have an informed decision. Being fed some legalese that forces you into decision to either accept the new terms and conditions or have a bricked product, that's not really transparent. And I think that connects with, I hope this, yes, the second one, which is agency. You don't have a choice whether you have this or not. And I think that's one of the fundamental principles that ethics in general should try to protect. With the last one, I think, being some of the most hairy, is around manipulation. What we fundamentally want to protect, technology aside, is manipulation. We don't want to change behavior without your participation, without your informed consent, without you having some kind of say in the matter. And I bring all of this back to the tool or weapon opening, because I fundamentally think that neurotechnology is a tool. But like this British professor, I can't remember his name, but he shared with me that if I really wanted to, I could strangle you with a garland of flowers. And I thought that was a really poetic way to explain that the onus, I believe, of where we're at should come down to the application and the decisions around wielding the technology, the tool, as opposed to the fundamental technology itself. And I think that those are improved with some of these additional considerations. And I come primarily from a small business interest where I have direct contact with the majority of my employees. So it's not exactly the same at a major corporation, but I think culture is a really fundamental tool that we can use to buffer better and intentional outcomes. Having people to hold groups accountable and to help lobby when interests collide, I think is really important. So being able to have that culture is one thing, but then being able to map the where the lines of influence come and fall, I think is also really important. For example, my company, we had to do a hard pivot in 2018. What we did was we had this killer demo. We had an integration with virtual reality that you could literally control a game with your mind. It's mind blowing. It got us the cover of the New York Times, but it was not a good product. It was not scalable. So we had to change the direction of the company. And in doing something called customer discovery, many companies do, we started to get several $100,000 check offerings from multiple consumer packaged good companies. They wanted us to do neuromarketing for them as a service. But we spoke with the team, and fundamentally, we didn't want to invest our blood, sweat, and tears into making this tool. And also, just like, what's it called? Altruistically aside, the value of the company gets capped if it stays as this one service, especially a service that you don't particularly care about. So I think being able to map incentive structures is really important, making sure that you have a board that's willing to support the direction and vision of the founders, and overall having healthy fundamentals, because Maslow's hierarchy of needs applies to a company just as much as it applies to a human being or animal. So that's the bulk of my presentation.